is video 1.3. Today we're going to be talking about square roots. Hopefully you've done square roots in the past and all of this is complete review for you. But a square root, this is the radical sign. That's the radical. What goes inside is called the radicand. And what's important to know is that in general, like if we were taking the square root of 36, we know that 6 times 6 is 36, and negative 6 times negative 6 is 36. But for the purposes of this class, pretty much, we're going to look for any time that it is written like radical 36. What we're really looking for is the principal root or the positive root. So we are going to say that we can take radical 36 and say that it is 6 and ignore the negative root because we are looking for the principal root. If I wanted the negative root, I would use the negative in front. So I would say negative radical 36 so that I could get the root negative 6. All right? Now, if I'm wanting both, then we'll use the sign, the plus minus sign. Plus minus radical 36 means I'm wanting both the negative and the positive roots. So when you'll just be using your calculator for the most part, but if you ever need to just kind of estimate a square root just to get an idea of where it is and it's one that you don't know already, let's say the square root of 34. That is not a perfect square, but we know that it is between square root of 25 and the square root of 36. Now the root of 25 would be 5 and the root of 36 would be 6. So this has to be somewhere between 5 and 6. So if we were to estimate it, we could just simply leave it at between 5 and 6. But if we wanted to get a little bit closer, 34 is closer to 36, so its root is probably going to be somewhere down in here, greater than 5.5. And if you're wanting to check farther than that, you can just plug it into your calculator. This one actually is 5.83. So that's pretty close. 5.83095, something like that. So when you're estimating it, if we're wanting to check and kind of see where things are, that can be a useful skill that you can just do in your head really quickly. So the properties of square roots. So the product property says that the square root of a product is equal to the product of the square roots of the factor. That's really confusing sounding. This is really what it means. So we can take square root of 12 and we can break 12 down to 4 and 3 on the inside. And we can break those 4 and 3 into two separate ones and take the square root of the 4 and leave the 3. That's the way we're going to simplify things. So if radical 12 is not simplified, we would need to break them apart to radical 3 is simplified because 3 can't get any smaller. But it also works the other way as well. So if you had, let's say we had in our problem radical 8 times radical 2, what you could do, you could break them down and then multiply them, but you can also just do square root of 8 times 2, which is the square root of 16, comes out to 4. So it goes both ways. Now the quotient property works the same way, it's just division. So you can go from having a division problem inside your radical and you can break them apart to a numerator and a denominator, take the square root of each one, and that would be the answer. If you put this into your calculator and you were looking for the square root of 25 divided by 16, you would get 5/4. And then it works the other way as well. So like if we had radical 18 divided by radical 2, that one, you can't take radical 2 and actually get a number 18. You could reduce it down a little bit. But if you go ahead and you stick them together inside your radical, 18 divided by 2, that's 9. And the square root of 9 is easy to find. It's 3. It takes a little practice to see how you can manipulate the numbers and put them together to see where you need to go. but I'm confident you'll be able to get there. So let's simplify some square root expressions. Let's look for simplification of negative radical 50. So what you need to think to yourself is, what factors of 50 are a perfect square that we could use? So the one that comes to my mind is 25. 25 times 2. So I've got my negative out in front. I'll do my square root of 25 and my square root of 2. All right. So now I'm going to take the square root of that 25. So it'll be a negative 5. And I keep my square root of 2 because it can't go down any farther. You'll know it can't go any farther if there are no perfect squares that are a factor of what's inside your radical expression. Then you know that you've gone far enough. If the only one that they have is 1, then that's far enough. All right, so let's do radical 2 times radical 18. So I'm just going to combine them together. That would be radical 36. I can take the square root of 36 easily. Principal root is 6. How about 49 over 81? So the first thing I always look at is, can I actually divide these numbers? If I can, I go ahead and divide them. In this case, I can't, so I'm going to break them apart. So I'm going to break this into radical 49 divided by radical 81. Square root of 49 is 7. Square root of 81 is 9. 7/9 is going to be my answer. Now in this case, when I look at it, my first thought is 96 divisible by 6? And it is, so I'm going to rewrite it and combine them into a single one. 96 divided by 6, which is the square root of 16, and the square root of 16 is 4. The other way you can do a division problem if you have a radical in your denominator. So in general, we wouldn't call it simplified if there is a radical in the denominator. You're not allowed to have it there. It's got to be in the top. So if you can't get it there by division, then you can get it there by rationalizing the denominator. So this is how you do it. Let's take a problem like this. What we want to do is we want to multiply this by a factor of 1, because what happens when you multiply something by a 1? You get the same answer, right? That was what we did in the properties yesterday. So what we want to multiply this, multiplying it by 1 is not going to do any good. But what fraction can we multiply it by where it's like it's a 1, but it changes our problem? That's what we're looking for. So what you want to multiply by, you're going to multiply the top and the bottom by something that makes that a perfect square. The closest thing that we can get to for that perfect square is to multiply the top and the bottom by radical 3. Okay? Because radical 3 times radical 3 is radical 9. So we have a square root of 9 on the bottom. On the top, our whole number multiplies by the whole number that's in front right here, which is a 1. So we'll have a 2. And our radicals multiply together, giving us a 6. And now I just need to reduce that. So 2 radical 6 over 3. And that's my answer. Most of the time, the easiest way to do it is just multiply by what you have already. Sometimes that's not necessary. In the case like this. So the closest thing that 18 is to a perfect square is going to be 36. So because 18 times 2 is much easier than 18 times 18. So if I multiply the top and the bottom by the square root of 2, on bottom down here, I will get the square root of 36. And on top, I would get the square root of 16. Okay, so now I can take the square root of 16 and get a 4. And on bottom, I can get a 6. And now I need to reduce my fraction, which is 2/3. All right, the last thing we're going to go over is adding and subtracting square roots. So if you'll think of a square root when you're adding and subtracting like you would a variable. If you have an x and a 3x, we could combine them because the x's are the same. Radicals work the same way. So if you have radical 2 plus 3 radical 2, we can add our coefficients because the radicals are the same. Now the radicals aren't going to change, so this would be 4 radical 2. Just like it's different when you're multiplying x's as when you're adding and subtracting x's, multiplying and adding and subtracting radicals are the same thing. So if you're adding and subtracting, your radicals have to be the same in order to combine them. And when you do, you are only looking at the coefficients and the radical stays the same. So here we go. We have 5 radical 2 and 3 radical 2. We can add them because they're both a radical 2. So what I want is my coefficient. I have my 5 plus my 3, which will give me 8. Keep my radical 2. Now at first glance, this one doesn't look like you would be able to combine them because we have a 3 and a 12. The thing is, this 12 is not as simple as it could get. So a 12 is going to be a 4 times a 3. So when I simplify that, I'm going to take my square root of my 4 and keep my square root of my 3, which would give me 5 radical 3 minus 2 radical 3. Now I can combine them. So I'm going to take my 5 minus my 2, giving me a 3 radical 3, and that's my answer. Have a good evening, and I'll see you when we get to class tomorrow.